8.2 Permutations of Different Objects, Part 1. So we have what we call factorials. So a factorial is a number evaluated all the way down to 1. So 8 factorial is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And there is a button on your calculator that will evaluate factorials, or you can type in 8 times 7 times 6 times blah 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 blah. Or you can memorize them, I guess, but it should be 40,320. So 4 factorial is 4 times 3 times 2 times 1, it's 24. 9 factorial is 9 times 8 times 7 times 6 times 5. 4, 3, 2, 1, and it is 3628880. And 10 factorial is the same as 9 factorial times 10, so 3628800. So that's a factorial. So it helps us arrange a number of n objects. So a puzzle designer decides to scramble the letters of the word education. So there are 9 letters in that, and there are 9 different letters. How many ways can they arrange those 9 different letters? Well, it's 9 factorial, so 3628880. That's how many ways you can arrange it. And we can do some simplifying with factorials as well. So if I wanted to simplify this, I have 5 factorial divided by 3 factorial. I'm going to rewrite the 5 factorial until I get to 3 factorial. Because once I get to 3 factorial, I have 1 on the bottom. And now I'm going to cancel. So I'm left with 5 times 4, which is 20. And we don't even need calculators. We're so smart. Okay, 12 times 11 times 10. And I'm going to stop at 9 factorial because I have a 9 factorial on the bottom. And I'm going to rewrite the 3 factorial. I'm going to cross out the 1 because it's just a 1. I'm going to go 12 divided by 3 is 4. 10 divided by 2 is 5. So I'm left with 4 times 11 times 5, which is 220. So there's lots of different ways you can cancel, but that is an example of one. Okay. You're given a ballot to vote for school council. There's 5 people in the ballot. Their positions are vice president, president, treasurer, secretary, and social coordinator. So if you're going to vote for all of them, you have 5 things to vote for, and you're voting for 5 of them. So we have 1, 2, 3, 4, 5 spaces. For the president, you have 5 people to vote for. Then you have 4 people for the next position. 3, 2, 1. And the only thing that was canceled was nothing. Alright, if we're only voting for 4 of these, we have 5 things in total, we're picking 4 of them. So I'd go 5 times 4 times 3 times 2. The thing that was canceled was 1 factorial. Let me write that properly. So we went 5 times 4 times 3 times 2 times 1, and the 1's were canceled, so we canceled a 1 factorial. We don't need to write equals. What am I doing? Okay, next one. We have 5 things to pick from, and we're picking 3 of them. So we have 5 times 4 times 3. What we needed to cancel was 2 times 1 to get to that. 5 and 2, we have 5 times 4. We needed to cancel 3 and 2 and 1. And last one, if I have 5 and 1, I have 5. I had to cancel 4, 3, 2, 1. So how is this related? Well, the first one I had to cancel 1, so 5 minus 4 is 1. The next one I had to cancel 2, so 5 minus 3 is 2. The next one I had to cancel was 3, so 5 minus 2 is 3. And last one, 5 minus 1 is 4. And it even works on the first one. 5 minus 5 is 0. So let's say I have n and I'm picking r things. That means that I'm going to cancel n minus r things. So on the top it would be n factorial, and we're going to cancel n minus r factorial things. So this is the formula for a permutation. So what a permutation is you have a total amount of things and you are picking some of them to arrange. So for instance, 8 students are competing in a 200-meter race. How many ways can students finish? First, second, and third. So the order matters. Who gets first, who gets second, who gets third. So it is a permutation because of that. We have 8 students, we're picking 3 of them. So that's going to be 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. So we could rewrite this as 8 times 7 times 6 times 5 factorial over 5 factorial. And we're left with 8 times 7 times 6, which is 336. We can also think about it as this is first place, this is second place, this is third place. 8 people can get first, 7 people can get second, 6 people can get third. It's the same thing. There is a pick button on your calculator. Some of you it will just be on the main screen. If you have like that pink calculator or the blue Texas Instrument calculators, you should have a PRB button, and inside the PRB will have your exclamation point, NCR, and NPR. So try typing it into your calculator with just this, because you should get 336 without having to do all of this work. Okay, example 2, when you have different cases. Okay, Tanya needs to create a password. She can use the digits 0 to 9 and or. The part that's important about this is the and the or. It can be letters or alphabet, so that's going to tell us what it's going to be. But what it's telling us is we can have a character of at least 5 characters to a maximum of 7. So this at least is the most important part because it tells us that we have 3 different situations. So we have one situation where we have a 5-character password. We also have a situation where we have a 6-character password. And the last situation is if there's a 7-character password. And any times you're dealing with more than one situation, you're going to add together your options. Okay, so it's a case-sensitive password. So for the letters, we have 26 lowercase and 26 capitals, so 52 letters. For the numbers, we have 10. So altogether, we have 62 things to pick from. So we have, and it is a permutation because it matters what order you put a password in. So we have 62 pick 5 plus 62 pick 6 plus 62 pick 7. So type that all into your calculator. It is a very big number, but you should get 2.5236907 times 10 to the power of 12, which is meaning that's scientific notation, so that means we could move our decimal 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're not going to actually write it. You can just write it like this, but it is a very, very large number because there are many, many options for passwords. Okay, so there's your first look at permutations.